We have another example on the board. Again, we're supposed to prove that the left side is equal to the right side. Like we said before, you can start from the either side. This time I'm going to start from the right side. I'm going to copy down tangent to alpha. And this is nothing else than the tangent of a twice of an angle. So I'm going to use the formula for it, which is this one. I can rewrite this as 2 tangent alpha over 1 minus tangent square alpha. Next, you're supposed to look at the left side of your original identity, and please notice that we have cosecant, we have sine, and we have cosine. That's why I'm going to use at this moment the quotient relations. I'm going to rewrite this fraction or this expression as 2 sine alpha over cosine alpha over 1 minus sine square alpha over cosine square alpha. This is equal 2 sine alpha over cosine alpha over, I have subtraction, 1 minus fraction. I'm supposed to convert 1 to fraction, which is 1 over 1. Find the common denominator. Common denominator for 1 and cosine square alpha is cosine square alpha. That's why I can rewrite this one as cosine square alpha over cosine square alpha minus sine square alpha over cosine square alpha. Let's take a look at what we have right now. We have 2 sine alpha over cosine alpha over cosine square alpha minus sine square alpha over cosine square alpha. Next, we're supposed to simply convert division to the multiplication. Okay, I'm supposed to write my equal sign over here. This is equal 2 sine alpha over cosine alpha. Division, the longest fraction bar is my division. Convert to multiplication and find the reciprocal of the second fraction, which is equal cosine square alpha over cosine square alpha minus sine square alpha. We have multiplication of two fractions. We can reduce cosine alpha and this square. Cosine alpha and square will cancel out, and I'm going to end up with 2 sine alpha cosine alpha over cosine square alpha minus sine square alpha. Next, we're supposed to look at the original identity. What we have up there? We have cosine, we have 2 cosine alpha, and we have cosecant, and we have 2 sine alpha. So what we're supposed to do over here? I'm supposed to use the Pythagorean relation and convert this cosine square to 1 minus sine square. Remember, Pythagorean relation says sine square alpha plus cosine square alpha is equal 1. If you are going to solve this relation for cosine, supposed to move the sign to the other side. And you are going to have cosine square alpha is equal to 1 minus sine square alpha. That's why I'm going to replace this cosine square alpha by 1 minus sine square alpha. I have 2 sine alpha cosine alpha over 1 minus sine square alpha minus sine square alpha. Why I did so? Because I need minus 2. Okay? Minus 2, and I need also cosecant. What am I supposed to do with this? This is equal 2 sine alpha cosine alpha over 1 minus 2 sine square alpha. Now, but I don't need square next to my sine alpha. I don't need sine in the numerator, and I need cosecant. So what am I supposed to do? I'm supposed to multiply this fraction by 1, but I'm going to make this one from 2 fractions divided by each other. They are 1 over sine alpha, and we have 1 over sine alpha. Why I multiply the numerator by this fraction and denominator by the same fraction? Because if I'm going to multiply by 1 over sine alpha, I'm going to eliminate this sine, and I'm going to create the cosecant, and I'm going to eliminate this square. So this is going to be, let me do everything step by step. I have 2 sine alpha cosine alpha over sine alpha over 1 minus 2 sine square alpha over sine alpha sine alpha. This is equal. Sine alpha and sine alpha will cancel out. Square and sine alpha will cancel out, and I end up with 2 cosine alpha over 1 divided by sine alpha is cosecant alpha minus 2 sine alpha. And this is nothing else, just the left side of our original identity. So it means that we prove that the left side of the identity is equal to the right side. Let's take a look at this example. Again, we're supposed to prove that the left side is equal to the right side. And I'm going to start from the left side this time. Let me copy this down. I have cotangent alpha over cosecant alpha minus 1. Look for a moment on the right side. Please notice that in the numerator we have 1 plus cosecant alpha, right? So I have to expand this numerator at least by something what has cosecant. So what am I supposed to do? I have to multiply not only numerator, but numerator and denominator by the conjugate of the denominator. I have cosecant alpha plus 1, and we have also cosecant alpha plus 1. Remember, you have to multiply numerator and denominator because this fraction has to give you always 1. Okay, cosecant alpha plus 1 over cosecant alpha plus 1 is equal to 1. 1 times this fraction is the same fraction, okay? So what we're supposed to do next? We're supposed to simply perform the multiplication. And we have cotangent times cosecant alpha plus 1 over, and in the denominator we are going to have the difference of two squares. Let me remind you the formula. We have a squared minus b squared is equal a minus b, and I have a plus b. Okay, so this is my a, this is going to be my b, this is my a, and this is my b. So I can rewrite this as cosecant square alpha minus 1. Next, I suppose to use the quotient relation and convert this cotangent to cosine alpha over sine alpha. Let's take a look what we're going to have. We have cosine alpha over sine alpha times cosecant alpha plus 1 over cosecant alpha. In the denominator you can rewrite as 1 over sine square alpha minus, and 1 you can convert to fraction, which will have denominator sine square alpha and numerator also sine square alpha, because sine square alpha over sine square alpha is equal 1, and I need to use sine square alpha because I have sine square alpha in the denominator. Next, let's organize the denominator, and we are going to have cosine alpha over sine alpha times cosecant alpha plus 1 over, subtract these two fractions, and you will have 1 minus sine square alpha over sine square alpha. Now, next we're supposed to realize that 1 minus sine square alpha is nothing else, just cosine. You're supposed to use the Pythagorean relation, which says sine square alpha plus cosine square alpha is equal 1. If you are going to solve this formula for cosine, you're supposed to move sine to the other side, and you will end up with cosine square alpha equals 1 minus sine square alpha. Okay, so you can have cosine alpha over sine alpha, and I have cosecant alpha plus 1 over cosine square alpha over sine square alpha. So this is nothing else, just cotangent alpha, and I have cosecant alpha plus 1 over cotangent square alpha. Okay, because cosine square alpha over sine square alpha is equal cotangent square alpha. Cotangent alpha and square in the denominator, they're going to cancel out, and you will end up with cosecant alpha plus 1 over cotangent alpha. Please take a look at the expression which we have just obtained and compare this with the right side of our original identity. They are identical. So it means that the left side of my equation is equal to the right side.